Previously, given a manifold M, we have associated to it a Lie algebra, namely the Lie algebra of smooth vector fields on M with the Lie bracket defined as in the previous video. Now, naturally, we ask, is this functorial? More specifically, we ask even a simpler question: does a map on smooth manifolds induce a map on vector fields? In particular, we want to ask, can we push forward vector fields? Naturally, you might feel, why not, right? We can push forward tangent vectors. Why can't we push forward vector fields? Because after all, aren't they just collection of tangent vectors? So let's see what the problem might be. Let's see if we can actually define this push forward. Let's take a vector field in M and let's suppose that we can actually define the push forward of X. The problem will arise, for example, if say that 2 point P and Q here in M that maps to the same point, say A in N. Then that would mean that both of these vectors have to map to the same vector here at A, right? Because there is the push forward by definition, and the push forward means both of these vectors have to map to this same thing under the different differential map. One under the differential map on this tangent space and one under the differential map here. Both of them have to map to this, but there's no reason that they actually have to. We can actually choose a concrete example where this can happen. For example, let's say M is R2 and N is R, and the map phi is just projection to say the first component. Then definitely we can find in R2 a vector field such that at 2 point P and Q that having the same y coordinate, the vector field is pointing into different in opposite direction with respect to the x coordinate. Then under the differential map, this two vectors, so let's say this vector, this blue vector, will map to here, and this green vector will map to here. So there cannot be a well-defined notion of push forward of this vector field, because if there was, then both of these vectors have, and actually all of the vectors along this line, have to map to the same thing, because all of these points here map to the same point. Thus, in general, we can't push forward vector field. But if the map phi though is injective, then we don't have this problem. In particular, if phi is a diffeomorphism, we can push forward vector field. However, besides diffeomorphism, there is another important class of cases where we can actually push forward vector fields. That's the case when M and N are Lie groups, and our map is a Lie group homomorphism. Then in that case, we can push forward left invariant vector fields on M. So let us define all of this terminology in the next video.